Hello, my happy Julian Mustangs. This is going to be Math Spiral Review, May 8th, Phase 3 in our distance learning. I'm going to go ahead and get started. So the first one, it says, find the product of 15 and 14. The key here is to notice that it says product. Product is answer to a multiplication problem. So because I see that the two numbers that I have to multiply together are double digit by double digit, I'm going to go ahead and make my box for this, because we have not learned the standard algorithm yet. So I'm going to go ahead and make these boxes. I'm going to pull apart the 15 into 10 and 5, and I'm going to pull apart this 14 into 10 and 4. So now all I have to do is add up or multiply the boxes together. So I'm going to start right here. 100 times 100, or 10 times 10 is 100. 10 times 5 is 50. 10 times 4 is going to be 40, and 4 times 5 is 20. My last step is to add these all up. So I'm going to add up 100 plus 40 plus 50 plus 20. And 0 in the ones place. 5 plus 4 is 9, plus 2 is going to be 11. Put down the 1, regroup my 1 here. 1 plus 1 is 2. So my answer to 15 times 14 is going to be 210. Okay. The next one, select all the expressions that have a value of 50. So this looks more complicated than it is. Well, we're just going to do some mental math here. So I'm going to start with putting 6 divided by 3. 6 divided by 3 is going to be 2, and then I'm going to add on 1, 2 zeros at the end of it. So 200. This is not an expression or a value of 50, so A is not the correct choice. For B, we have 5 divided by 5 with 2 zeros, or 500 divided by 5, which is going to be 1 with 2 zeros at the end for 100, which is also not a value of 50. Let's move on to the next one. This one, it may be very tempting to do 2 divided by 4. However, 2 divided by 4, you're making a smaller number, splitting it into 4 pieces, you're going to get a fraction or a decimal. So instead here, we're going to add this extra 0, and we're going to do 20 divided by 4 with 1 0. 20 divided by 4 is going to be 5. With 1 0 at the end for leftover is going to be 50. So C does have a value of 50, so that's one of the possible solutions. Let's keep going to make sure that we're not missing any more. The last one, I'm going to do 4 divided by 4, which is going to be 1, with 2 zeros at the end for 100, not a value of 50. And last but not least, we're going to do 25, oops, sorry, I meant for that to be a highlighter, 25 divided by 5 with 1 0 at the end. 25 divided by 5 is going to be 5 with 1 0 at the end for 50. That means this is also the correct parameters. So some of the ways, or the expressions that have a value of 50 are going to be C and E. Next one. Write a greater than, less than, or equal to complete a true statement about each pair of fractions. With fractions, we have not talked too much about this. There are several ways you could have gone about it. But the thing is because they have different denominators, we can't just go by numbers alone. One of the ways I like to do this is break it down. I see that my numerator is bigger than my denominator, or this top number here. So I'm going to break it down. My denominator is going to stay 2, but I'm going to pull out one whole of 2, 2. And then I'm going to pull out what's left over. So I have 2 as my denominator still, but 2 plus 1 is going to give me that number 3. So I can see that 3 halves is going to be the same thing as 1 whole, which is 2 and a half. Okay. If I go over to this other side and I break down this number, I'm going to see that my denominator is 6 here, so I'm going to keep my denominator 6. I see it's a number greater than 1, so I'm going to pull out 1 whole, which is 6, 6. So this is my whole number. And then I'm going to pull out what's left over. My denominator stays 6, but then 6 plus what gives me 9. So 6 plus 3 gives me 9, which means that 9 6 is equivalent to 1 and 3 6. So now that I see that I have one whole here, oops, I did not mean to erase that. Now that I see that I have one whole here and one whole here, what's left for me to do is just to compare the fractions, 1 half and 3 6. What I know about fractions, though, is that I know that 3 is half of 6, which means that I can also have an equivalent fraction. So I'm looking at 1/2, and I know 1/2 is equivalent to 3/6. And if you want, I'll prove it. 1/2 times 3/3, or 1 whole, is going to give me 2 times 3, which is 6, and 1 times 3, which is 3, meaning 1/2 is equivalent to 3/6. So these two fractions are actually equivalent fractions, or equal to each other. It's just the same fraction, but they go by different names. Next, find the sum of these fractions. I always, when I'm looking at fractions or dealing with fractions, look at the denominators, or the bottom numbers, and I see that this one's an 8, and even though this is bigger, this is still a denominator of 8. So, keeping that in mind, I'm going to keep my denominator 8 because I'm adding, not multiplying, so my 8 stays here. What's left for me to do is to add up 3 plus 1 plus 2. So 3 plus 1 is 4, plus 2, which is going to be 6. So my answer here is going to be 6/8. All right, name the place values that are missing. So this is something that we've been talking about in Zoom meetings because this is really important to know. When we have the place value hundreds, tens, and ones, decimal, on the other side of that, we get tenths. Let me go ahead and highlight it pink here, and I'll highlight this pink here. We get the word or the name tenths. It's a 10 with a THS at the end. That is this place value right here. So for the next place value, I'm going to do it in blue, which is going to be here. So just like in our other side, we have tens and then we have ones. Same thing here. We're going to have our tens place, and then this one right here is going to be our hundredths place. Spelled 100 with a THS at the end for hundredths. And that's this place value right here. Keeping on with this pattern, I bet you could guess what the next place value would be. It would be thousandths with the THS at the end. That's correct. And you could keep going on like that until you get to a trillion if you'd like. For this last problem, it says, look at the names of shapes in the tables below. Put an X to show which attributes apply to each shape. The word attribute just means like a characteristic or if they have it. So it sounds fancy, but it's really no big deal. So when I'm looking at something like a square, so I'm going to draw just a real quick square. When I'm looking at a square, I know that a square does have a right angle. It has parallel lines here. It has parallel line here, meaning these two lines, let's go draw in pink. These two lines are parallel because they're straight up from one another and they'll never touch. They could go on for infinity that way. I also have a parallel lines here and here. These two lines in blue are also parallel to each other and they will never touch. Therefore, a square does have parallel lines. Perpendicular lines are any two lines that come together that make a 90-degree angle. So if I were to draw something like this, these two lines would be perpendicular because right here would be that 90 degrees. So a square, since it does have a right angle, is also going to have a perpendicular line. So yes, it has those things. Now, for a right triangle, I'm going to go ahead and draw that shape over here. For a right triangle, that means that it's a triangle with a right angle. So if I draw a right angle triangle like this, okay, there's my right angle. A right triangle does have a right angle. Obviously, that's why it's called that right triangle. It does not have parallel lines, though, okay? That's something that you will not see in a right triangle. There are no two lines on a right triangle, no matter how you try, that are never going to touch. So this is going to touch the pink line, and this is going to touch the blue line. There are no two lines on a right triangle that are not going to intersect and create something else. Last but not least, it has perpendicular lines. It does because it creates a right angle. So again, if it has a right angle, it also has those perpendicular lines. The next shape that we look at is an acute triangle. An acute triangle just means that all the angles are acute. There is not an obtuse angle. There's not a right angle. They are all acute, so they're all small. So I'm going to go ahead and draw that to the best of my ability. So with an acute angle, or an acute triangle, it does not have a right angle because all the angles are going to be less than 90 degrees. It does not have parallel lines because all the lines touch. And it does not have perpendicular lines either because there is no right angle. So that one has nothing in it. This one's basically not there. And last but not least, we have an isosceles triangle. Now, isosceles is referring to the sides, but it's not referring to angles. So you can draw an isosceles triangle a couple of different ways. Isosceles means that two sides are the same and one side is different. So I can draw an isosceles triangle like this, where I have two that are the same size and one that's slightly smaller. I can also make an isosceles triangle like a right angle. If this side is the same as this side, and then I connect the two, this also creates a right triangle. So even though it is a right triangle, you could say it is a right isosceles triangle. That's the one I'm going to focus on, and I think that's where the trick was lying here. So isosceles triangle does have a right angle, or at least it can. It doesn't always have to, but it can. Again, it's a triangle, so it's not going to have parallel lines, and it does have perpendicular lines because if I make an isosceles triangle correctly or as a right triangle, then it's going to have perpendicular lines as well. That's it for today's math lesson. I hope you enjoyed.